As a kid, did you ever wonder why hot objects tend to glow or emit light?
I've thought of it once, but how exactly does such occurrence come to be?
Let's find out the science behind this phenomenon. When an object is heated to a high temperature, its atoms vibrate. This excites the electrons to a higher orbital, which then emits energy in the form of visible light as it returns to its ground state.
I'll demonstrate. This is a tungsten filament bulb. Currently, it is not emitting any visible light. However, as I send electric currents through its filament to increase its temperature, you will notice how it starts emitting yellow light.
You have just observed a phenomenon referred to as blackbody radiation. Now, why is it called a blackbody in the first place?
Since we associate black with light absorption, this was later assigned to a material that could theoretically absorb light at all wavelengths and emit radiation.
However, do note that no material can truly be a black body. At the same time, a material doesn't have to be a perfect black body to emit blackbody radiation.
For better comprehension, let's have another demo. This box is an example of a black body. It's not entirely black, but effectively, what you see through the hole indicates that all entering light is absorbed by the body itself. Its blackbody radiation isn't visible only because we're at room temperature, whereas the bulb was hot enough for its radiation to be seen.
If our box was at a high enough temperature, we would be able to closely replicate these curves, which demonstrates two visible trends.
As temperature increases, the area under the curve also increases. This explains why the hotter a bulb is, the brighter it glows, because the energy emitted is proportional to its temperature.
This idea was modeled by Max Planck in 1901 using the expression where energy is equal to integer times Planck's constant, which is equal to this value times the frequency of radiation. This means that the vibrational energies of atoms and the electromagnetic waves emitted by electrons are quantized.
Hence, at a certain energy level, there's not enough thermal energy within the black body to induce the vibration of atoms at frequency required. Thus, it drops to the left.
The real mind-blowing idea here is that energy is quantized, such that a certain car can only travel at certain speeds provided by its engine power. Like a black body would also be emitting energy at a certain frequency and wavelength because its electrons can only have discrete values.
This became the beginning of quantum revolution and why the notion of quantization and most quantum mechanical phenomena did not pop prior to the early 20th century.
So the next time you think of glowing objects, remember that any material emits electromagnetic radiation in quantized amounts as a result of its temperature. It's nice to know things beyond what we can see.
Just like blackbody and quantum revolution in modern physics.
A possibility exists from being unaware of being unconscious to being aware of being unconscious.
I'm Rolando P. Anson III.
Angela R. Avila,
And Franz Maria Marzala.
Your companion in seeking knowledge in science.